which is just a regular magnifier. But who need it, while we can print our own on 3D printer? In this video, you'll see how I turned this into perfectly clear plastic, designed the ideal lens shape and actually got it to focus light. And all of this on a 3D printer. Watch until the end so you can achieve the same results, because this took me a whole month. You're watching Mr. Fock, my name is Petai Farseni, and enjoy the show. Who even need a 3D printed lens? I'm making it only for a video and for a portfolio maybe, kinda. Okay, don't think about it. Better I'll show you what nobody in the whole internet did it before. Really, if you search in YouTube or in Google, there's exactly 0 videos about 3D printed lenses. So who else if not me? At first I designed the lens itself, right in Orca Slicer, not in CAD or Blender, cause for what if it's just a squeezed sphere? But I can just put and print it like this. By default printers print on textured PE plates. There's of course and not textured smooth ones, but I don't have such plates, so I decided to just put piece of glass on my plate. By the way, in old days everyone used glass, there was just no PE plates. If we want the best transparency, we can't use textured PE. Of course, it's too much distortions. And I'm not saying what textured is bad. It looks cool and it's more convenient in practice. Of course, I can't just fold a bit the glass to take stack printed workpiece, like with these magnetic plastic fields. I suggest printing the first lens without any boring calculations right now. Just calibrate it after installing the glass and start printing. It is actually much better than I thought, unexpectedly. Because theoretically lenses with such a structure shouldn't even at all focus the light. Okay, I'll draw what I mean. Marker leaked. In short, it's about lens shape and light rays. In normal lenses everything is okay, I think you got it already. Rays hit the surface and deviate just like it should basically. Meanwhile 3D printed lenses let the light through in some places, and whereas the other part scattered light every which way. Well, seems like my theory is wrong. Kinda strange, isn't? This lens had layer height 0.3 millimeters. So you know what I'm gonna do now. Usually everyone set layer height to 0.1 millimeters to 0.2 millimeters to achieve the best quality and printing speed. Especially in my case, I did it exactly for achieving the best transparency. Less layers, less distortion. Therefore, due to the previously discussed reasons, the subsequent lens was printed using a 0.1 millimeter layer height, representing the threefold reduction. In comparison with previous one, the focal point has the same brightness, but there's less light around the edges. Even though it focuses a bit better, it's way less clear. You might be wondering what would happen if we combine it with 2 lenses, since most real lenses are double-sided. In my case it doubles not focal strength, but the opacity. There's absolutely no merit in these actions. I know you wanna see how a real magnifying glass focuses light for comparison. Now you see it. Now the first lens is already finished. I adjusted some parameters. For example, flow rate is a bit decreased, because on the previous one you can see how the excess filament just oozes out because of the overflow. And the result is what the light focuses. I can't really see, it's cloudy now. Okay, let's when I'll show you the visual difference between 0.1 and 0.3 millimeters height. Hey, are you enjoying this video? Am I doing it okay? I wanna know, because I'm just starting my career. Okay, now you understand me. Let's continue then. Starting with this moment, I had more and more problems. So, I decided to slice this time in fill with concentric shape, not align it. And it's not a problem. The problem is that my glass has shifted. Starting with first layer, my lens already was failed. But that's not the only issue. By the end, the lens also shifted from the bed. Okay, I will glue the glass when if it's a problem. Maybe by the way it's because this lens has concentric and fill, but theoretically, after all, concentric should focus light much better when aligned, but not in this time. Yeah. Even so, I wanna show you. Look how mirror-like smooth this surface. Enough printing lenses just by guesswork. I suggest we now spend a couple of minutes studying the scientific theory behind how to actually make the most efficient lens. I did a whole research project on this, so just enjoy. Okay, let's talk about the shape of our lens. This topic would be a good fit for the Have You Ever Wondered video series. I think the most of people just think about lenses like a glass circle with a bulge in the center. But the shape of bulge is what? Is it a squeezed sphere or a cutted sphere? Or it's a parabola? Now I'm drawing the diagram to clearly show you what I mean. It matters because it directly affects how well the light will focus. Okay, the first way to make a lens with what I come up is just squeeze the sphere. Literally just a flattened ball. From the side view it will look like an ellipse. I mean, look. Some lenses really look just like this. The second lens shape is the parabolic one. If you don't understand why I even mentioned such a convex form, remember the satellite dishes. If you don't know, this shape is parabolic too, as satellite dishes and lenses both has a focal point. Because of it all, the parabola is exactly what we need. Its feature is to concentrate absolutely all rays in one point. Yes, circles have a very similar form, but a bit worse, cause the focal point is a bit blurred. Besides, as long as you make it less convex, the focal point becomes more sharp. Therefore, this small arc seems almost just like a parabola. And making the arc bigger increases the difference between parabola and the arc. I looked it up on the internet, and yes, this shape is the most correct one. And the third one. It's a cutted arc. We use 3D lenses, so it's called spherical cup. Now you know each of 3 types. So, which one is used in production? Yes, factories produce both types, and parabolic and arcs. And yes, parabolic is still better. But it's a feature of production, what spheric lenses are much cheaper to produce, because literally, polishing with circular motions polish the spherical surfaces. There's no need to polish lenses only if we're at the start casted with the needed parameters. But often in production at start it's a semi-product, a pack, what shape is made with CNS later and polished on machines. Oh, you don't know how the lenses are produced on the fabrics? I completely forgot about that. Let's step by step. First step. It starts with a raw plastic blank. We tape the front to protect it. Then we lock it down with a warm wax. Next is cutting. A CNS machine curves your prescription. It works with nanometer precision. Step 3. Liquid polishing. The cut lens looks milky. We polish it until it's crystal clear. Then we melt the wax and wash it. Step 4. Time for coating. We dip it in lacquer for scratch resistance. When vacuum coating eliminates all glare. Step 5. Final check. Finally, quality control analyzer checks the prescription accurately. An inspector looks for tiny defects. Done. Meanwhile, how I'm making lenses. There is actually one more type of lenses. They are completely flat but focus light just like regular lenses. Interesting technology. At the end of the day, I should at least make a normal lens properly first, before tackling a Fresnel lens. They are so flat thanks to thousands of tiny steps. Basically 90% of usual lenses is just a useless spent of material. I don't know why you haven't heard of their existence, but they, for example, was used for a long time in we are set. Now we put even more complex lenses in them, called pancake lenses, where light reflects several times, every time losing its brightness, which structure allows them to be very thin and distortion free, but of course it requires a super bright screen. While company owners decide to make lenses spherical or parabolic because of the production features, I can easily print any type on my 3D printer. So I decided to first model each type of lens and run a simulation in Blender before printing them to determine which one works best. You can see on video I'm struggling why my lenses has no focus. It turned out that I forgot to check one box in preferences. How I made the parabolic lens? Let me show you. In Blender, turn on the mode what allows you to move adjacent points within a certain radius and choose the parabolic mode. Then add a circle to the scene and fill it with a grid. Then you can grab a center point, adjust the radius and just push it. When Blender crashed, so I did it all again. Here is the render to comparison. The right one is spherical, in the center is squished sphere, and in the left is parabolic. Yeah, now it's obvious what squished sphere is a very bad lens. Even a regular glass sphere works like a lens, but it's still slightly worse than a flattened one, with a very close focus point. But I should say on this video it works surprisingly well. So, the left one parabolic and the right one has no such a distortion. The parabolic one through has a bit smaller dot, so it should be for real a bit better, but I don't really care. When I decided to compare the parabolic lens and the spheric, more precise, more close. And just look, yes, it's two different lenses. The difference is so immense. In cameras and other even more precise things, it maybe matters, but I'll just ignore it. Okay, we've dealt with what, let's move on. The second question what bothers me is the thickness of the lens. I lined up 3 lenses with different thicknesses in order and rendered a small animation. Interesting thing is what in the lowest position focuses are very similar, if not the same. But in the topmost, the difference is huge. And it is the only reason between different thicknesses. Let's slow down the animation even more to get a better look at the details. The second thing what I noticed is what with lens what rotates has with distortions when it's tilted away from the light source, just like real lenses. So I think my simulations can be considered physically accurate enough, don't you think so? If you noticed, light doesn't become brighter in focal points for some reasons in my simulation. I asked AI about it and searched on the internet, but I found nothing. If you are profi in Blender or something, you can give me a tip. Okay, now we know all the necessary theory. Let's now with our new upgraded mindset do the best ever lens printed on 3D printer. That's how I made my lenses before. And now I'll show you how I'm making now. It's not a squished sphere now, like it was before. Again, now it's just a cup of very big sphere. And when with the first print, something goes very wrong. It was even strange. Turned out what that hop was too small. Somehow, because I even did the calibration before printing. I wouldn't dwell on it if my glass weren't completely covered with scratches because of it. Even so, I can't resist what the lens itself turned out really good. It's even the most transparent one so far. Here's the comparison with other lenses, and if I'll put it on the text, I can even read the text under this lens. And if you're interested in, this is how this lens looks on macro. And it passes the light focusing test very good. And it's with 0.3mm layer height. And what will be if I'll even polish it? So I'll just adjust the Z offset and let's print it again. Looks like everything is much better than the previous one, but at the end some layers are shifted because the extruder while printing shifted the glass under it. And with small defect, maybe not was small, but it causes what the light doesn't focus anymore at all. One of the worst results. And yet, with glass and with pegs are so much more problematic than you can think. Because every time the extruder moves, it makes a very scary noises and almost breaks the peg. One time it really broke one peg. This time I decided to print and fill aligned, not concentric, and the result was surprisingly well this time. But the surface is something, of course. And for real, in test it focuses the light really bad. At first I tried to polish it with a needle file, but it was quite slow and not really efficient. So after like 15 minutes I decided that I need a real sandpaper. And better if it would be 800 or 2000. So 2 days later I went to the store and bought 2 lists. But I noticed something strange. Is it okay what P2000 and 800 look absolutely identical? By the way, touching the paper with my fingers feels like the 2000 even sharper. To understand what's wrong, I studied the meaning of the letter P and investigated the manufacturing process of this sandpaper. I thought the number on the sandpaper is the amount of sand grains per centimeter. I was totally wrong. If what were true, P2000 would be a mountain of sand. What number actually stands for the mesh size of the sieve used to filter the grains at the factory. It counts how many holes fit into one linear inch. A P40 sieve has 40 big holes. A P1000 sieve has 1000 tiny holes. And what's the letter P? It's the European FEPA quality standard. It guarantees every single grain is calibrated to the exact same size. Without the P, one random big rock can slip in and ruin your entire paint job. But on the manufacturing, machines don't dump the sand on the top. We use millions of volts of static electricity to shoot the grains upward. This forces every single grain to stand straight up, making the paper razor sharp. We bake it, lock it with a top coat and chop it into the sheets. Boom, ready to send. Was all good, of course, but my lens after polishing became matte and even a bit colored red. What stinks, I won't do it again, and even after washing. So you know, becoming matte is the worst thing that can happen to the lens. With it for comparison my usual lens. I haven't given up on the idea of polishing the lenses properly. I decided to try another way. I took my rotary tool, basically a simple electromotor with different tool bits. I used felt polishing wheels. Weigh exactly what is used for high gloss polishing. Are you interested in how it looks in slow-mo? Okay, let's just hold it tightly. Well, okay, nothing interesting, let's keep it. By the way, the result wasn't interesting at all too. So I polished another one, but only one half, to make a good comparison. Yes, with the felt polishing wheel, the surface is still matte, not as much as with sandpaper, but it's still critical. Here's the previous polished lens again. I remembered what the lenses should actually increase the picture, and if you look closely, look, It really increases the picture a bit. By the way, have you seen this font stand? I used it everywhere. If you're interested in, I modeled it myself too. And it can regulate the height and the angle. And also, as I noticed, it card sized. If you want, you can download it on my Boosty. In Orca Slicer you can adjust the layer height in every point. So let's make a test if doing only the topmost layers thinner is a good idea. The result. I'd say rather there is no anything special. Just a normal result. Well, how normal? It's not enough normal. I'm trying to increase the quality, of course. So I'm not satisfied with it. A new experiment with infill now. I'll try to make it spiral, not concentric like before. It has a lot of pros. For example, there won't be any seams. It means that my lenses will be more transparent. And also, as I'll know later, the layers will print exactly one on another. It means no air gaps, so even more clear lenses. I'm shocked, to be honest. This is the comparison. Wow! Camera can't show it, but it's crazy. It's crazy, bro. This light in point is much brighter than other. I'll increase the extrusion a bit and it will be even better because between walls there's a bit. Wow, it even falls apart because of the gaps. But I think I can say it's success. The glass has shifted very hard again, so I did a calibration. Now I'll remove the walls at all. My next printing was fucked up, and next is again, and the problem is, I wanna say, I don't know why, I searched, but I still don't know why. Vertically everything goes bad, but horizontally there's still huge gaps. Just look it insane. And don't pay attention to my fingers, the glass is a bit dangerous, you know. So it's a problem now. Because the light like this focuses much worse when it can. And this is the result with extremely increased flow ratio. Yes, it failed again. Not like we're really smaller, maybe a bit. I thought it will be much better. If you don't understand why my prints always fails with these lenses now, in the top layers the nozzle pushes the print really hard. So I can't even with my hands hold it. So still this one is the best. I don't know how it's not failed even. To solve the shifting glass problem, I came up with mounting it with a double-sided tape. It should hold better when the clips through. I left them on too. What a mockery! It's just an abuse on me. Seriously. Printer's nozzle just molds the surface and the inside. At the bottom there's still gaps. Seriously. I absolutely don't know how to fix it. The only solution now is to make the lens as thin as I can, but it's not a solution, we should be honest. So I'll try now to make this lens 2 times thinner and print it again, but with even more flow rate. Now I set, while printing with flow rate 1.7. It's insane. Okay, flow rate x2, the size smaller x2 too. Gaps still worse. Shit at the top still worse. And what should I do in this situation? I literally have no solution. The only thing what I can do now is to ask you help me. Okay, Now look at this turtle. She's crazy, by the way. With these all good exemplars I have, and I made a small stand to test them. First, let's discard the most unsuccessful ones. Bad, of course bad. With this. Very bad too. This should be quite good. Well, not that bad. Bad. I heard some noise. What it was? Another bad one, of course. Wait. Yes, bad. It focuses a bit, but really matte, so bad. Quite big, quite transparent, but should be not really good. Quite good actually. Okay, I'll put it. So here's 4 best ones, I think. Let's compare with polished one. The focal point is too big, but concentrate the light not bad actually, because it's quite bright. Next one. Here the focal point is quite bright and small, but why the distance to the surface to focus is so small? It's too bad. Now this one. Quite bad. Okay. And the most transparent now. Yeah. I like this one. This one is my favorite, of course. So, it's our champion. So, if you wanted to print your best lens on your 3D printer FDM, print it with spiral infill, with wide and tall lines, without walls, very slow, like 20 millimeters per second, and on 270 Celsius, and of course on flat surface, like glass. But honestly, I don't know why you would need such a lens. And yes, this lens is not that bad, for real. My final lens give or take as good as my English. And just do not forget, if you don't want to lose my channel, you can press one button. See ya. What are you doing, Dasha? You find a place? Good place, да? Kid.